Oh, so turns out my mic was not working. All right, well, we fixed that. As you can see here, I made this nice little infinite generator for triangles. So now I could go and generate good triangles basically forever. I'll get back to that in a second, see how far it went. Anyway, unlike Java or Pascal, Haskell has type inference. All right, that's pretty classic these days. True is a boolean, hello is a string, etc. Let's use GHCI to determine the types, right? Use T. So then, let's do that. Oops. It's some kind of number. Okay. Interesting. This shouldn't exist. If I do this, it's a list of A. Yeah. What about if I do this is some fractional A? So again, these two are generic. It doesn't know for sure what you're doing with them. But if I do it like this, it's quite clear what is going on. Or say let x equals 4.0 as a float. It should just say float. There we go. But if I were to just write 4.0, oops, it could be any fractional A, which is reasonable. I wonder if the same happens for strings. Okay. Well, I heard strings are linked lists, so that might not be fun. Let's see how the number generator is going. Okay, it's getting to reasonable numbers. Getting me some triangles. Pretty cool. So this is just going on. That is nice. That is pretty nice. And you can also take the type of tuples and stuff like that. Square brackets denote a list. Yep. Okay, well, it seems I have crashed VS Code. Okay, that is interesting. Hmm. Maybe triangles ran out of space or something, but that shouldn't happen. I'm gonna check memory usage. I'm gonna run this again. Hmm. Yeah, it really takes up memory. Whoa. A leak or something? What's going on? I feel like it shouldn't. Whoa, whoa, whoa. Hmm. Well, that's not great. The fact that it takes up all that stuff. Huh. Okay. Functions also have types. Alright, so let's take the type of function like it has. Take some kind of A and then returns that A as it should be. Cool. Let me turn this light on. Remove non-uppercase takes a list of characters and returns a list of characters. Here's a simple function that takes 3 integers and adds them together. Cool. I know this, that you do that. You can always just write the function without it and check it with t. Cool. Int stands for integer. It's used for whole numbers. 32-bit machine. Int is capped at the usual 2 to the 31 minus 1, right? Yeah, that should be that number. And then negative 2 to the 31. Integer stands for basically big int, so you can get some really big numbers. This is cool. All right, let's see this then. Factorial n equals product of 1 through n. And then let's get, you can get some big numbers in here. Why not? I mean, computers are fast, so big ass number. All right, wait, 1 sec. All right, back, and now it's cool. So you can just do and even sum all the factorials up. So just to be sure, that's okay. So let me sum up all the factorials from 1 to 100. I think that did it. You could probably also sum factorial 1 to 100. That seems a bit cleaner to me. But yeah. Neat. Float is a real floating point with single precision. Double, okay, sure, double. Bool is a Boolean type. Have only 2 values. I guess. Yeah, I don't know. I don't know how you define it. Bool definition. It's an enumeration. Okay, this I do. Data bool equals false or true. You have and, you have or, you have not, you have otherwise. Pretty cool? Pretty cool. Otherwise is defined as the value true. Could have been called else, but whatever. Char represents a character. It's denoted by single quotes. A list of characters is a string. Then you have the empty tuple, which is same as Rust, like a unit type. It can only be an empty tuple, and you'll use it sometimes. So if I just do this, that's the type of it. And I can see here, this is num takes an enum a. Do I really need this? Enumerable. So that makes this range possible. If I were to take like, I don't know, integer into integer, that should be fine. And there shouldn't be an issue with that. So like, yeah, all good. What do you think is the type of the head function? Because head takes a list of any type and returns the first element. So let's see. Yeah, it takes a list of A and it returns that A. So it's a type variable. Although type variables can have names longer than 1 character, we usually give them names of A, B, C, D. Okay. FST takes A and B, returns an A. Cool. Yeah, they don't have to be the different types. Like, I could have an int, and that would still match A and B. Type class is a sort of interface that defines some behavior. They're not like classes, they're like Java interfaces. Okay, probably more like Rust traits, I guess. Okay, let's see it then. This won't work, right? I gotta do take some A, which can be equatable, and then it takes another one of that A, and it returns a Boolean. Cool. If a function is comprised only of special characters, it's considered an infix function. If you want to determine its type, you gotta pass it as to another function or call it as a prefix function with the surrounded in parentheses. So we can do this. Cool. We can also do this. Pretty nice. Pretty neat. Oops. Everything before that symbol is called a class constraint. Oh, cool. These are class constraints. So this says that A is equatable, and then it says, okay, well, it takes an A and another A and returns Boolean. The equals type class provides an interface for testing for equality. So let me check it then. Data.eq. And let's see what the source is. What? No source? Hmm. Well, that's not great, but hmm. So it takes equals and not equals. I'm sure not equals has a basic default definition, which is just, you know, not equal. But something like this, a maybe do it like this. Yeah, so if I do, I'm gonna get overload. So let me try this. Let me put a tick here. Well, cool. So we basically just wrote not equals. But yeah, that's probably how the default definition would look for it. Did I just turn off my camera? Dude, I don't know how that happened. So far, some technical difficulties today, huh? Alright. At least you could hear me. Right, yeah. Or it is for types that have an ordering. Ordering is a type that can be either GT, greater than, less than, or equal to. Either? What about greater than, equal? Oh, I'm dumb. Yeah, that can't happen. That cannot happen. Right, because that's just a single function that compares the two values, so numbers of show can be presented as strings. So I can do, oops. Cool, I can do yeah. There we go. read is the opposite. I can do read. That's kind of cool. What? No parse. What does it want me to write parse? Huh. Oh, you have to specify the type. Okay. Alright. Cool, that makes sense, honestly. Yeah, so this is kind of silly. I could guess this is 16 letters. Well, that's not helpful. P, right? Read is sort of the opposite type class. Takes a string. Okay, yeah, we just did this. I can even do cool stuff like this. Oh, nice. Actually, let me ask now, will it be able to do this? Right, because it doesn't know what I want. If I say read this as list of integers, it can do it. One sec. Right, I'm not gonna wear headphones, so I'm just gonna. There we go. So, let me see what else is happening here. Right, so if you do read for, just like I was saying, it doesn't know what it wants. Right? I mean, it can figure it out though. If you have some function that takes an integer, even if you do like abs of read, or it shouldn't really. Well, I guess then it knows what you want. Alright, that's fair enough. Yeah, so a case like this, it would know what you want, even in a case, obviously that doesn't work, but in a case like this, it would know what it wants. So it returns a type that's part of read, but we don't try to use it in some way later. It has no way of knowing which type. That's true enough. That is true enough. And we can even see here the type of read should be the opposite of the type of, oops. Right, so this takes a into a string, this takes string into an a, which is pretty nice, pretty simple. What GHCI is telling us is that it doesn't know what we want in return. Notice that in the previous uses of read, we did something with the result afterward. That way, GHCI could infer what kind of result we wanted out of our read. If we used it as a boolean, it knew it had to return a bool. But now, it knows we want some type that is of the read class. It just doesn't know which one. Right? Yeah, so you can do this. Now here's the question. Do you even need, oops. Obviously this will work. I'm not convinced you need it though. Yeah, you don't. Unless you know, if you do this though, funny, cool. Enum members. So this is a type class of something that can be ordered. Or enumerated at least. So you can use it in a list range. Sure enough, that's fair. types in this class include this stuff. I don't know why this one's here. But alright, whatever. Bounded members have an upper bound, lower bound. Okay, cool. So these are polymetric constants. That's cool. So it's just a single thing, which means it's basically constant, but it exists on multiple types. That's pretty nice. All tuples are also part of bounded if the components are also in it. That's cool. So I can go and do right. I would want to specify the type like this. A single integer is this. Now, this shouldn't be bounded, right? Yeah. So integer doesn't implement bounded, which makes sense because by definition it goes on forever. And there's no negative either. Right, so that's cool. You have num, which is a numeric type class, which means it has to act like a number. Appears that whole numbers are also polymorphic constants, not metric, polymorphic. They can act like any type that's a member of the num type class. So that's kind of cool. So it's kind of like this. So it's like more like constant, which can act like different types. The same way some functions can, because functions with no parameters are constants, basically. If we examine the type of star, we'll see that it accepts all numbers. Brilliant. Pretty cool. Any number, it takes two of them, and it returns a new one. I'm sure plus would be the exact same for like minus, same for like, okay, this one, fractional. Now if I do div, that takes integrals. Okay, I mean, sure, why not? But this is not a thing. Okay. Right, you can't do this because these are different types. This will produce an integer because 5 can act like an integer or an int. To join num, a type must already be friends. Okay, so it has to implement show and equatable to be a number. Okay, I guess that's kind of arbitrary, but sure, why not? Integral is also a numeric type class. Num includes all numbers, including real numbers and integral numbers. Integral includes only whole numbers. And then you have floating. So these are the more general versions from integral. Takes an integral number and turns